Up to this point, our best tool for showing that arguments are valid or invalid, or for showing whether sentences or sets of sentences have various semantic properties, has been truth tables. But as we'll see in a minute, while truth tables will always work for truth functional logic, they do have some disadvantages. This lesson will give you an overview of the natural deduction method that's going to replace truth tables. The aims of this lesson video are pretty simple. First, you should be able to recognize the limits of truth tables and why we're moving on to using this system of natural deduction. And the other purpose is just to give you some basic familiarity with how proofs in the natural deduction system look and work. When we looked at truth tables, they were a fail-safe way to determine whether arguments of truth functional logic were valid or invalid. But for these purposes, it turns out they have two major limitations. The first is simply filling in all these columns of trues and falses. Though it does allow us to get an answer to whether an argument is valid or invalid, it doesn't help offer us much about why a valid argument is an instance of good reasoning. Particularly if we want to be able to apply our reasoning rules to ordinary arguments used in everyday contexts, it would be nice to have a better sense of what makes good reasoning. The second issue with truth tables is just that as arguments get more complex, it's really easy for truth tables to get outrageously long really quickly. For example, if you have an argument with just 7 different atomic sentences, that would require a 128 line long truth table, and I don't think any of you would be happy doing one of those. The system of natural deduction will be our replacement. Natural deduction will be a system that allows us to show that an argument is valid, among other properties. The way it works is that it uses a core set of basic inference rules, rules that characterize good reasoning, and those rules capture how more complex arguments can be constructed from basic reasoning steps. So the idea is, by relying on a core set of good inferences, we can track good reasoning from premise to conclusion. In this way, natural deduction solves the problem that truth tables had. It gives us a better sense of why an argument is good, because it better matches the kind of natural steps you might make as a human reasoner to go from premises to arrive at a conclusion. The other advantage of natural deduction is that by relying on these core sets of rules, we can get around having to test the validity of an argument by looking at every possible evaluation, the thing that made truth tables get long quite quickly. The inference rules that we use instead in the natural deduction system will correspond with valid argument patterns. So we'll be able to check that an argument is truth-preserving, our goal with truth tables, without having to individually examine all the ways that sentences in an argument could come out true or false. The inference rules will capture that element already. Instead of tables, the natural deduction system offers rules for constructing formal proofs. Formal proofs start with some set of assumptions. In this case, that will be the premises of an argument in truth functional logic. And then the natural deduction system gives us rules for moving from those assumptions to prove a conclusion based on those assumptions. Because these are formal proofs, the proofs in natural deduction will all have to have a certain basic structure. So the core elements are that every line has to be numbered. And the point of that is it allows us to easily track the steps of the proof and to refer back to previous steps, something we'll need to do when we invoke the rules. The proof starts in its first lines with the assumptions, the premises that we're going to use. And the last line should be the conclusion. Then, for each line, in addition to being numbered, so we can distinguish each step, each line is also justified by some rule that tells us how we got to add that line to the proof. Let's look at an example to see those elements of the proof in place. So our goal right now is not to work through every detail of this proof. We're not quite ready for that yet. But I want to give you a basic sense of how these proofs are organized. So at the top here, we see a familiarly organized argument in truth functional logic with premises A and B, and if B, then not C, and the conclusion not C or D. Our goal will be to construct a formal proof, one that uses some simple inference rules to show that we can arrive at the conclusion of this argument from those premises. The proof itself is these 6 numbered lines below the argument. Lines 1 and 2 are the premises. So compare lines 1 and 2 of the proof to the premises of the argument above. You see the same sentences. To the right of the sentences, we see these labels PR. That's to mark that those first 2 lines are premises. And since those are our assumptions, they're also separated from the rest of the proof with this horizontal line. The horizontal and vertical lines will both be important to the organization of our proofs. But we'll see how they work when we get to some of the details of the rules. Lines 3 through 6 reflect applications of the rules of the natural deduction system. Note again that each one of those lines, 3, 4, 5, 6, is a sentence of truth functional logic. Then to the right is our justification for writing that sentence in the proof. For each justification, the rule used is named, as are any lines earlier in the proof that we had to use to apply those rules. So for example, if we look at the last line, that uses a rule called disjunction introduction. So we see VI as our abbreviation for disjunction introduction, and it's applied to line 5. So the number 5 is there to tell someone who looks at this proof that the rule was applied to line 5. That last line is the conclusion of our proof, and we should see that our proof worked because the last line is the conclusion of our argument as well. And with that, we now have a basic sense of how proofs in natural deduction will be constructed, at least as an overview. And that will allow us to move on in the next video to getting comfortable with some of the most basic proof rules and how to use them to construct your own proofs in natural deduction.